machines often have heavy loads to lift or pull. Whether it's a dragline excavator working in an open pit mine, an oil drilling rig, a construction crane, or farm machinery, the weight is borne by ultra-strong wire ropes. Industrial wire ropes typically range from 0.8 of an inch to 5 inches in diameter. Besides machinery applications, they also serve as support cables for large static structures such as bridges and stadium roofs. Manufacturing a wire rope begins with steel wire that's anywhere from 3/1000 of an inch to 3/10 of an inch in diameter. The first step is to wind several of these wires together into a strand. How many wires per strand depends on the job the rope will perform, because different applications require different degrees of flexibility and strength. Each wire is spooled onto a steel bobbin and loaded onto a stranding machine, which is essentially a giant winder. There can be as many as 64 wires in a strand, although the typical range is between 19 and 36. The twisting wires converge in a die that forms them to the required diameter. Lubrication is critical, and not merely to help the wires move smoothly through the die, it also penetrates within to allow slight movement between the wires. This increases their lifespan and prevents the strand from seizing. The strand exits the machine saturated in lubricant. A large rubber band skims the excess off the surface. The strand now travels through a row of straighteners. These heavy rollers apply vertical pressure, effectively erasing the wire's memory of being spooled on a bobbin prior to stranding. This prevents the wires from unraveling. This cross-section shows all the wires inside the finished strand. The clothespin gives you a sense of its size. Wire strands are, by themselves, typically used as structural support cables. To make wire ropes used in machinery and for heavy lifting, they take several of these wire strands and wind them together on a far bigger and stronger machine called a closer. They make this particular rope from 6 wire strands. Before the strands converge in the die, rollers pre-shape them into a corkscrew-like form. The strands then enter the die, twisting together over a core, which is itself a small steel wire rope. A core at the center of the cable provides additional strength. This cable's finished diameter is 3.5 inches. However, there are always small variations here and there. So now 4 calibration rollers, 2 compressing vertically, 2 horizontally, correct the cable to the right diameter all along its length. The finished cable winds onto a big steel reel, ready for shipping. The factory tests random samples in its quality control lab. There, a machine measures the tensile strength, how much pulling force the cable can withstand. The machine pulls the cable at both ends until it snaps. For this mega cable, the breaking point was 104 tons. To pass the test, a cable must exceed the tensile strength it's designed to withstand. For certain demanding applications such as mining, wire ropes are double-coated in plastic to protect against wear and tear. To prepare the plastic, the factory mixes a recipe of clear and colored plastic pellets. An extrusion machine heats the pellets until they liquefy, then forces the molten plastic through a die, coating the rope as it passes through. As the rope exits the extrusion machine, it passes through water, which cools and hardens the hot plastic. The plastic not only jackets the rope's surface, it also provides cushioning when on the job site, the strands inside rub against each other as the rope moves. By reducing wear and tear on the steel both internally and externally, plastic coating can extend the life of a rope by up to 50%. A cable's internal construction determines its strength and flexibility. A structural one needs to be strong, immobile, and taut, so it's a single strand made of large wires, whereas a moving rope in large machinery contains many strands made of smaller wires.